Okay, so what is supervised learning for regression problems? Supervised learning is a branch of statistical learning problems where there is a target variable in the data set to supervise the learning process. So there is a target variable, and this target variable supervises the learning process. In other words, the method tries to, so the method, I mean any supervised learning method that we use tries to learn how a set of predictors are associated with the target variable. This is about supervised learning in general. Two examples. A machine learning method tries to detect existence of a condition. So this is a target variable, existence of a condition. This is the target variable based on a set of symptoms, and these symptoms are predictors. Another example, a machine learning method tries to figure out how a set of features of a news article, such as title, the day of the publication, the author, the topic, etc. So these are all predictors, are associated with the number of readers of that article. This is target. In the first one, the target was a categorical variable. In the second one, the target is the number of readers, right? So the target is numerical. Supervised learning problems are categorized based on this variable type of the target. If the variable type is numerical, then we have a regression problem. And if the target variable is categorical, then we have a classification problem. So regression problem is the topic of this week's lectures. And regression problem is a problem in which the target variable is numerical. From the examples that I gave, the second one is an example of a supervised machine learning of a regression problem. So there is no structural difference between the classification problems and regression problems except for these differences. But let's go through the similarities first. Still, so it's better to say that there is no structural difference between classification and regression problem. So what you have learned for the classification problems is still applied to regression problems. We still split the data set into training and testing. And training is for learning, testing is for evaluation of the learning quality, is for performance evaluation of our model. We still use supervised learning methods for learning. So there are methods that can be used for learning, either in classification or in regression. We still evaluate the quality of learning by measuring the prediction quality on the testing set, as I mentioned here. So what is the difference? Except for, the performance metric. This is the important one. The performance metric for regression problems are different. The performance metrics are different. Regression problems have some exclusive methods as well. So if you recall, we learned decision trees. For classification, decision tree is one of those methods that can be used also for regression. So we are good to go. We have the tool to actually practice our learning in seminars. And still, there are some methods that are exclusive to regression problems. Okay, and you cannot use them for classification. Yet it is not the time to talk about different methods. We should still remain focused on the concepts of supervised learning regression. So the main performance then boils down to this performance metrics. the way that we evaluate the predictive ability of a model for regression problems is different from the way that we used to evaluate the prediction ability of a classification method.